Welcome to class today. Today's topic is section 2.6 algebra functions. And one thing I want y'all to realize today is what's going to be guiding our discussion are the four steps we've been discussing pretty much throughout the semester. You know, the first is you always want to state the formula or formulas that you're using. You want to label the relevant data in the problem. You want to substitute, and you want to solve. So one of the things that I was telling you the other day is this actually helps you organize information, and since this is a QEP class, you know, one of the elements of the thought deals with information. So if you have a solid process that's consistent in organized information, I believe that will help you throughout the semester. And these four steps will apply pretty much from now until finals. Okay, so for today's topic, we're going to talk about the algebra of functions. We're really going to be honing in on this third step, which is called substitute or substitution. Okay, because function evaluation all boils down to that one word, which is substitution. Okay. So let's talk about some common operations on functions. Okay, so the first operation is a sum. And the notation for that would be f plus g evaluated at x equals f of x plus g of x. And the thing I want you to realize is this does not read f plus g times x. The way this reads is f plus g evaluated at x. Just in the same manner that the f of x is not the same thing as f times x. It's f, the function f evaluated at x, okay? So let's just do an example to make sure this is clear. So for example, suppose we're given f of x equal x squared, g of x equal x plus 1, okay? So those are the two given functions, and our problem is to determine what is f plus g. Find f plus g evaluated at x. So that's our problem. So as you can see, you know, throughout the semester we've been doing this four-step process, okay? And the formula that we're using now is the sum formula for functions. This is the formula. We're trying to find f plus g of x. So if you state the formula, well, that's the formula that we're stating, okay? If you label the relevant data from the formula, well, you'll notice that the f of x is basically the given of the problem. It's x squared. The g of x is also given. It's x plus 1. So what's the next step in our process? We're going to substitute. And if you substitute into the formula, all you have to do is replace the f of x with what you labeled, correct? What did you label to be? X squared. The g of x was labeled to be what? X plus 1, right. I'm going to put these in parentheses just for emphasis. So we substituted in x squared plus x plus 1. And since there are no like terms, you can't combine any of these expressions. So the final answer is going to be x squared plus x plus 1. This is the final answer. So f plus g evaluated at x is x squared plus x plus 1. Okay? Now, let's talk about this whole idea of domain. For this problem, we say, or for this formula rather, the domain is given to be d subscript f intersected with d subscript g. Okay? So what does that mean? What that means is the domain of the sum of the functions is an intersection of the domain of each of the individual functions, okay? So one of the things I told you a few weeks ago is if you don't see a rational expression, or if you don't see a radical, what do you assume the domain to be? Anybody remember? All real numbers. Okay, so since the domain of x squared is all real numbers, and the domain of g of x is all real numbers, then the domain of f plus g of x is also what? All real numbers.
Is that an N?
Where? No,
That
the formula.
Oh,
okay, sorry about that. Yeah, good question. So this is the symbol for intersection. That's a very good question. So because you can think of the domain as a set of numbers, intersection is one of the operations that we perform on sets, okay? So if you recall, for real numbers, all real numbers, so write out like this, all real numbers can be expressed many different ways, right? So if you want to express it in terms of a number line, you basically draw a number line, zeros in the middle, this is minus infinity, this is plus infinity, okay? You can also express it as an interval notation, so that's minus infinity to plus infinity, okay? So these are two common ways you can express all real numbers, but what this symbol represents is anytime you're dealing with sets you don't do things like plus or minus, those operations that you perform on numbers. With sets, you do operations such as intersection, and does anybody know what the other operation is? Ends with a U. Does anybody remember the term union? Union of a set, okay? But this is not a union, this is an intersection, so that's a good question. All right, so the next thing we're going to talk about is difference operation on functions. Okay, so as you might imagine, for a difference, all you do is replace the plus with the minus. So you're just going to subtract the functions. So this means f minus g evaluated at x equals the first function f of x minus the second function. Okay? So if we rework our example, we said that f of x equal to x squared. We said that g of x equal to x plus 1, correct? So f minus g of x. So now I'm actually going through the same four-step process again, right? I'm stating the formula. F minus g of x is equal to f of x minus g of x. I'm labeling the relevant data. Well, the relevant data here from the formula is f of x and g of x, that's given, correct? So I told you that our key phrase or keyword we're going to focus on in this class is substitution. That's what functional evaluation is all about. But if we substitute in what f of x is, we get x squared. We bring down the minus. G of x is simply equal to x plus 1. Anytime you substitute in a negative number or an expression, it's always important to use parentheses, okay? Because we're going to apply the distributive property to this particular problem. So we have x squared. The minus sign distributes to the x and to the 1, correct? So that's our final answer. And as far as the domain goes, the domain of f is all the real numbers, correct? because you don't see a radical here, you don't see a rational expression, correct? The domain of G is also the real numbers, okay? So that means the intersection of those two domains, which would be f for f minus g evaluated x, is also going to be real numbers, okay? All right, so let's go on to multiplication or product. So our next operation is called the product. So for a product, we have this notation, f g evaluated x equals f of x times g of x, okay? So that's the term for a product, or the expression for a product. And the way you read this is f g evaluated x, f times g evaluated x equals the first function times the second function, okay? And the domain is still going to be the intersection of the domain of the first function with the second function, okay? So let's go ahead and redo our example. So we were given f of x equal x squared, g of x equal x plus 1. We essentially go through our four-step process again. And I realize that, you know, these examples are pretty simple, but I want you to get used to using this four-step process on simple examples, because when things get complicated, this will still work, okay? So that's what I want you to keep in mind. So I realize you're probably saying to yourself, well, I can do all this without the four-step process. But that might be true, but when things get a little more complicated, that will come in handy. But let's make sure we understand it for something simple, and then we'll apply it to something more complicated. All right, so if we apply the first step, we state the formula, well, that's the given formula. If we label the data, that's actually given in the problem. G of x equals x plus 1, f of x equals x squared. So we made it down to this key step, it's called substitution or substitute. So our goal is to find f, g, evaluated x. That's what we're trying to do, okay? That's the problem at hand. So to find that, we essentially substitute f of x into this formula, so we get f of x, which is x squared, times g of x, which is x plus 1. And guess what? We've done most of the hard work. To multiply these two functions, you do what's called the distributive property, correct? Because we're using parentheses, so this distributes to the x, so we have x squared times x plus x squared times 1. So let's make sure, I'm going to pause here for a minute, make sure there are no questions. Does everybody understand how I got from this step to this step? I just used what was called the distributive property. Everybody clear on that? Okay. All right, so one thing you may have learned in the previous class is if you have a common base, like x here, and you're multiplying, does anybody remember what you do to the exponents? You add them, okay? So there's not an exponent listed here, but the assumption is there's always a 1 here, because x raised to the 1 power is always going to be x, okay? So that's going to be x to the 2 plus 1 plus x squared, because another rule for math is if you multiply something by the number 1, you just get back the original something that you started with, right? So this is going to be x to the 3rd plus x squared for the final answer, okay? But one thing I do want to make you aware of is if you get to this point, you've pretty much proven that you've understood the problem. This is really dealing with what was called which step? The solve step. So if you got to this point, you've gotten 3/4 of the problem right. Because this is how I grade the exams typically. I'm grading the majority of the problems on the exam based on your ability to follow these 3 steps. So if you state the formula correctly, you get 25% credit on the exam. You label the data correctly, that's 50%. You substitute, which is basically doing this step here, you've gotten a C on the problem, correct? And then everything else is just solving out the problem, all right? So let's move on to the next thing, which is a quotient. All right, so for the quotient, as you might imagine, we're going to divide the functions. So we have f over g evaluated at x. So again, this does not read f over g times x. This reads f over g of x, or f over g evaluated at x, okay? So that's going to be f of x over g of x. Now, the domain here is going to be similar, but it's going to be one little catch to the domain, okay? Erase this. So the domain is still going to be the intersection of the domain of the first function with the second function. But what do you notice here? We have a rational expression now, don't we? What's the rule for rational expressions? Well, denominator can't be what? 0. Right, denominator can't be 0. So we have to apply additional restriction to the domain, which is the denominator. That was one of the rules we learned, right? Denominator for anything. Anything in life, denominator cannot be 0, right? Is that a true statement? If you take out your calculator and you divide 100 by 0, your calculator will give you an error, right? So this is a general rule for all mathematics, is denominator can't be 0. But specifically for this problem, the denominator is what? Let me look at it. What is it? G of x, right? So I'm going to substitute and say g of x cannot be equal to 0. Is everybody clear on that? So the domains for the sum, difference, and product are all going to be basically this. But with quotients, you have to apply an additional restriction, which is the denominator cannot be 0, because a general rule for math is denominators can't be 0. All right? All right, so let's do an example. The same example we've been working with before, right? So, example is f of x equal x squared, g of x, what do we say equals to? X plus 1. All right. We're going to follow again this 4-step process that's going to guide us through the whole semester, right? The first thing we do is we state the formula. There it is. What's the next thing we do? We label the relevant data from the problem. Well, the relevant data that relates to this formula is already given in the problem. F of x equals x squared, g of x equals x plus 1. So I'm actually labeling my mind, because previously in previous lectures we actually labeled it on the board, but here it's explicitly given, so we just labeled it in our mind, okay? And the next thing we're going to do is substitute into the formula. This is the formula that's given. So since our goal is to find f over g evaluated at x, that's our goal, we're going to basically substitute the f of x into that formula. So when we do that, we're going to get x squared for the numerator, right? For the denominator by substitution, we're going to get x plus 1. And guess what? You're going to love this. We're done. I mean, that's all there was to it, okay? Because, so in this situation, we stop after the substitute step, okay? Because there's no way you can simplify anything else here, okay? Now, there will be some problems you have for homework where there will be an additional solve step because there'll be things you have to simplify. You may have to cancel some of the terms in the numerator and denominator. But for this particular answer, you cannot simplify this any further. So is that clear to everybody? All right, so let me ask you a question. For the previous 3 examples that we did, the domain was all real numbers, right? Because the intersection was going to always be real numbers. But for this problem, the domain is still all the real numbers, right? Can someone tell me what the exception is? The exception is what? This, correct? So as relates to our example, g of x, we labeled it to be, because that's given, right? X plus 1, right? So by substitution, x plus 1 cannot equal to 0. Is that clear? Subtract 1 from both sides, you get x can't equal to minus 1. And that should make sense to you because if you plug in a minus 1 into that answer, can someone tell me what happens? You get 0. And what's the general rule for math? You can't divide anything by 0. That's undefined. Okay? All right, so the final thing I'm going to talk about as far as concept is composition. Okay? That's going to kind of tie things together. And after I do that, I'm going to, maybe work a homework problem just so you can be comfortable doing the homework. Because after today's lecture, you should be able to do any homework problem in chapter 2.6, okay? And if you read chapter 2.6, it should all make sense to you, okay? All right, so that's the point of the lecture. We want to make sure that you understand the basic terms so when you go back and read the book or do the homework, you're able to get through it. So, composition. Now this one is probably, in times past, this one has been sometimes the hardest to understand I've seen from various students. So if there's any questions, please stop me. I'll try to go slow on this particular one. All right, so before I do composition is evaluating a blank of a blank. Anytime I do fill in the blank, it means it's a very important concept, and it could be a question on the quiz, okay? This is a very key concept that you need to understand. So composition is evaluating a function of a function. So this is a very key concept, okay? So make sure that you commit this to memory. Composition is evaluating a function of a function. Because up until now, primarily, we've been evaluating functions of x or functions of a number. So what do I mean by that? So up until now, let's take our example again. When we had, say, f of x equal to x squared, we're used to evaluating f, say, at the number 3, that's just going to be 3 squared, correct? We're used to evaluating f at some other variable, let's just call it a, and that's going to be a squared, correct? But what composition is dealing with is dealing with evaluating a function of a function. So here we're doing a function of 3, evaluating f of x at 3, getting 3 squared over 9. We're evaluating f of x at a, getting a squared. So a function of a function would be f of not 3, not a, but I'm going to really highlight this. It would be f at g of x. Now, would you agree that is a function of a function? It's not a function of a number. It's not a function of another variable like a. It's a function of a function. So is that clear? So here, the answer was, and I'm going to use parentheses just for instance, okay? Here the answer was 3 squared. Because like I always tell you, you should always substitute with parentheses. It's not really necessary if it's not a negative number or not an expression. Everybody remember that? So, but I'm doing this just for highlighting purposes. F of a is a squared. F of g of x is just what? G of x squared. Same thought process. Is everybody clear on that? You substitute in a 3, you get 3 squared. Substitute in a, you get a squared. Substitute in g of x, you get g of x squared. All right, so it's the same thought process, all right? So let's go ahead and talk about the notation for, so did everybody write this down? Okay, so I'm going to go ahead and talk about the notation for composition. So the notation for composition, I want to make sure I'm consistent with the book, is F compose G of x equals F of G of x. And I kind of talked about it over here, right? All right, so that is the notation for composition. The domain for composition is still going to be the intersection of the domain of the first function with the domain of the second function. All right? So let's go ahead and rework the example we've been working all class, okay? So let's go ahead and do that. So our example was f of x equal x squared, right? And g of x equal to x plus 1. Our goal is to find f compose g of x. Okay, so I want to talk about the symbol. This is a simple composition because we talked about addition, that's the plus sign, subtraction, that's the minus sign. You know, multiplication, that's typically a dot or a times sign. And division, you know, we've seen this before, that's the divide by sign. But typically, for division, we just do a fraction like a over b. That's a quotient, okay? But the symbol for composition is this little open circle. It's almost like a degree symbol, okay? All right, so let's go ahead and, again, we're going to follow the what? The 4-step process. So I told you this 4-step process will take you all the way through finals. It's a way to organize what? Your information. You know, that's what this elements of thought for the critical thinking paradigm. All right, so we state the formula. There it is, that's the formula. Well, in exam, what I want you to do is I want you to rewrite the formula on your test paper, okay? Because that's crucial for you to understand which of the many formulas to pick, okay? And you'll get 25% credit just for doing that. We're going to label the relevant data. Well, it's already labeled for you, right? F of x equals x squared, g of x equals x plus 1, right? We're going to substitute because remember I told you at the beginning of class, this is the key thing we're going to be doing today is substitution. So if you substitute, you're going to get f at g of x. Well, so what I'm doing is, in fact, for this problem, because it's a little complicated, I know I did this before, but I want to do it for this problem. I do want to follow the 4-step process pretty explicitly. Okay? So let me do that over here. Because this one's a little bit more complicated, so I'll make sure I don't lose anybody. So, number 1, we're going to state the formula. Okay? Erase this to get some more board space. Well, what's the formula? f compose g of x equals f of g of x, right? That's the formula. So I'm going to erase this to gain some more board space. All right, what's the next thing we do? The next thing we do is label the data. So f of x was given to be x squared. G of x was given to be x plus 1. So you've gotten halfway there, right? The next thing we're going to do is substitute into the original formula of what we're going to substitute what we labeled into the original formula. So that's going to be f compose g by the way that x is going to be f of g of x. Well, what's g of x? G of x is what? X plus 1 by substitution. Is everybody clear on that? And then, this is where it gets a little tricky, okay? So before I evaluate the next thing, I'm going to ask you some questions, okay? Just to bring back to remembrance what function evaluation is, which relates to one word, which is what? Substitution, right? So we know what f at 0 is, right? It's just 0 squared because this is the original function, right? It's f of x with x squared, right? We know what f at 1 is. It's just 1 squared, right? We know what f of, let's say, the letter b is. It's just b squared. Okay? Here's a silly example. We know what f of, let's just say, a clock is. It's silly, but it's going to drive the point home. It's just a clock squared, right? F of x plus 1 is x plus 1 squared. That's the answer. Same thought process. If you know it's f of 0 is 0 squared, f of 1 is 1 squared, f of b is b squared, f of a clock is a clock squared. This is silly though, but it's driving the point home. F of x plus 1 is just x plus 1 squared. But remember, this is the answer.
You said f of a clock.
It's a silly example, but I'm doing it to drive the point home, okay? All I'm saying is, it all boils down to one word. That one word is what? Substitution, okay? All right, so now in the homework, I think they want you to do a FOIL on this, but everybody's comfortable with FOIL, right? It's just going to be x plus 1 times x plus 1, which is going to be x squared plus 2x plus 1. So when you do the homework, you might see this in the back of the book, okay? But once you get to this point, you've proven to me you understand the concept of composition, okay? All right, so now we've covered pretty much everything, all the operations and algebra functions. So what I'm going to do now to kind of wrap up things is I'm going to work one of the homework problems, and then we'll call it a day, okay? All right, so this is section 2.6. This is very important that you practice everything we did today, because if you don't, you might find it hard to believe. This might seem easy now, but if you don't practice it, you're going to probably forget it by Friday, okay? So it's very important that when you go home, you practice all this. All right, so let's do number 79 from the book, okay? So this is number 79. We have f of x equal 2x plus 3. G of x equals x minus 3 over 2. Okay? We're going to, first thing we're going to do is we're going to find f plus g evaluated x. Well, all that means is just add the functions. So you have 2x plus 3 plus x minus 3 over 2. Okay? Now, because this is a fraction, you can't combine them, right? You have to have a common denominator, correct? The easiest way to produce a common denominator is to multiply this by 2 over 2, because 2 over 2 is the same thing as the number of what? 1. And 1 times anything doesn't change what this means, correct? All right, so that's going to be, if you distribute this 2, that's going to be 4x plus 3, I'm sorry, 4x plus 6, right? Over 2 plus x minus 3 over 2. Now the denominator is the same, right? So what I want you to understand is this means the same thing as the original expression, which was 2x plus 3, okay? Right there. So now the denominator is the same, we can combine the expressions. So 4x and x is going to be 5x plus 3 over 2. That's the final answer. Okay? F minus g over x is going to be, basically, we did the word denominator over here, correct? So we can use that result and say 4x plus 6 over 2. I'm going to make this all one fraction because the denominator is common, right? Minus x minus 3 equals, well, 4x minus x is 3x. 6, well, minus a minus 3, that's going to be a plus 3, right? So it's going to be plus 9 over 2. That's the answer. So is that clear? Now the next one is going to be multiplication. F times g of x is basically taking the two expressions, 2x plus 3 and x minus 3 over 2 multiplied. For now, I'm just going to stay there, but basically what you can do is you can do a FOIL, take out the 1/2, but I'm going to stop here because, you know, you've proven the concept here. So let's go on to the quotient. So the quotient is just basically saying f over g of x equals 2x plus 3 over x minus 3 over 2. But the rule is when you divide by a fraction, that's same thing as multiplying by the what? Begins with an r. Reciprocal, so that's going to be 2x plus 3 times 2 over x minus 2. So the final answer will be 2 times 2x plus 3 over x minus 2. All right? So that's the quotient. And we're going to wrap up with what? The composition. That's the last thing we're going to do now, is composition, okay? So it's very important, please, when you get home, it's very important that you rework everything I did on the board here. Because if you don't, you're going to forget this by Friday, okay? So please, everything I'm doing on the board, please rework it without looking at the notes. And then once you're done, look at the notes and you should get the same answer that I got, okay? So the last thing we're going to do for the day, then you can you'll be dismissed, is composition. So this is the last thing we're going to do for today, is composition on this problem. So we have f compose g of x. We know that's equal to f of g of x, right? And let's just recap. We know that f of 0, this problem is going to be what? What's f of 0? F of 0. Plug in 0 to the f, the function 2x plus 3. What's f of 0? 3, right. What's f of 1? What's f of 1? 5, right. That's 2 times 5. Because remember, it's substitution, right? That's a key word here, substitution. F of the letter b is what? 2b plus 3. I'm going to do the silly example again. F of the clock equals 2 times a clock plus 3. It's silly, but it drives the point home, doesn't it? Now, let's do the f of g of x. That's going to be 2 times g of x plus 3. So is that clear? Using the same train of thought. I'm using the same train of thought. Is everybody clear on that? But here's the extra trick here. G of x is given to be what? X minus 3 over 2, right? So we have to do another substitution. So 2 times x minus 3 over 2 plus 3. That's substitution. Everybody see that? The 2's cancel out. You get x minus 3 plus 3. The 3's cancel out because 3 minus 3 is just 0. So the final answer is x. So that concludes today's lecture. Please rework everything I did today so that it sticks. If you have any questions, feel free to ask me now or ask me after class. Wow.
So for each problem, we apply every formula to that one problem, or that was just you doing that?
That was me doing that. Because in the book, they actually, for the first part, they'll ask you to do summation, difference, product, and quotient, and where the later parts will actually do a composition. So I combined it just to conserve time.
Okay.
Okay? You should be comfortable doing all of them with any problem.